So this is my window where I had dropped my order, and my order actually had 756 files. I did not download it back then, so for the reason that, I mean, obviously I'll never be downloading an order online. Uh, Usually when you go to this order page, this is where you can download it from. But if I download it in front of everyone on a recorded session, I risk sharing some personal API keys, which I use for download. So that is not something that is appropriate. But you will actually be getting a link here from which you can download all of your files easily. My order might take another 5 to 10 minutes to be ready. And all that you need to do is just click on the orders page and your order will be ready to download. So what is for today's exercise? For today's exercise, I have done something different based on similar data. I have a data for 1 year, that is 12 months. So what I'll do is I'll share that with you. I'll go to my virtual machine. Sometimes it does throw an error and fails to start, but that should not be too much of an issue. I'll show you the files that I'll be using today. If you go to this folder here, these are some images for 1 year that I have, and I could very much use them in my database. And if you want, you could obviously go for downloading your modest data. That would be your daily data. So I am in my FOSS GRAS workspace. First things first, I would like to create a separate workspace for myself. One of the reasons for wanting to do that is so that my data is properly organized. It was 2001, the folder. I'll clear this one. So this is the data that I have. To get some information on my data, I can use this GIDAL tool. So what I can do is I can type GIDAL info and the file name, and it will give me some information on the file. GIDAL info is a very powerful command that is useful for many GIS related functions, and this is why we do so. For that matter, if I wanted to save this information somewhere, I could just put the greater than sign and type GIDAL info dot txt, maybe underscore example, and I can then open GIDAL info example file. I misnamed the file So ignore that part. But now this is saved in a text file in the directory where my files are. I'll get out of it, remove the glad info file. Now I would need to create a workspace for my exercise. Just let me do one little tweak. I just need to turn off some mics and get back to you. Just 1 second. There you go. This is just to I had to disable mic for everyone to be able uh, to avoid any background noise. So what I would be doing is I would be, of course, now importing this data in GRASS GIS, but I need to create a separate database for it. So what I would do is I would type r.in.jidal, which is our standard import command for GRASS -e input lst _1 maybe .diff, and then I'm going to name an output file as the base file and then give a location a name that is modis lst. Since you have seen that it is WGS84 World Geodetic System, so there's no issue with the projection. I'm gonna press enter. I mistyped. There you go. So my output file is now created. I'll now go to my GUI, refresh it here, shift to the modis LST map set that I just created. Just to keep things clean, what I could do is I could delete this base file without any issues. And then I could do the I could do the bulk import. It would import all my files for me. And based on that, I'll have g.list. If I would like to see the raster maps, I'll get all my raster maps in here. So I have 1 to 12 maps for each month each. I clear my screen because there's always this lot of error messages. This is something that is not very good to look at. So I usually press the clear screen button and I'm all done with that. The next thing that I need to do is one more thing. I don't know why it is so, but I need to exit it and I need to start grass again. There was something that I'll show you that was a bit bothering to look at, but I don't know. In the previous screen, I don't know if you noticed it or not. There was 2001 written here, and that's something that I don't think was to some bug, I think. Oh, I don't know. I don't get it why it was. Now, once we have our time series data imported, we could definitely have a look at it in the map display and see what our maps look like. So this is what my maps look like. There's a variety of functions in GRASS that you could use to display this data. For example, the r.color. So the r.color is a utility that can be used. Yeah, r.colors is a utility that can be used to modify the color table associated with a raster map. Now, since my rasters are land surface temperature maps, I would want them to uh, look more like temperature. So I would look for a color table that actually represent temperature. And here, if I look at this list of options, I don't really have a temperature option, or do I? I have a Celsius option and I have a Kelvin option, and I might have a Fahrenheit option somewhere as well. Yes, I have a Fahrenheit option as well. I would like to see the values on my rasters first. So I'm going to list my rasters, and I have a list of raster here. I'm going to type r.info and get the info on one of my files. When I take the info on my file, I'll get to know what the units are. And if you see, the units for the minimum data is minus 40.26 to a maximum of 39 degrees Celsius. So the range of the temperature is suggestive that this is a degree Celsius data, and I would rather than set the color map in the degrees Celsius. So I have to give the name of the map, and then I also have to actually set a color table. So for that, what I would be doing is r.colors, and then I'm going to type the map name. It was on my clipboard, so I'm going to paste it, and then I'm going to give the color option as Celsius. I'm going to press enter. Now it says that the color map for the LST2001 underscore 1 has been set to Celsius. I'll go back to my layers, turn off the rest of the layers, and I'm going to probably have to remove it and then reopen it because I don't have a refresh option here. So since I don't have a refresh option that I can see on the screen, I'll just remove these maps from here. I'm going to go to this map, and this now looks more like temperature. And that's one thing that I did. But when I click on another map, I have a different issue. And usually it's very convenient to be able to do it for all your maps. And one thing that this offers is this r.colors option is that you can actually copy it from existing maps. So if I want to do it for _2 map, what I could do is I could go to LST and then type raster and type for the map 2. Let's say if I would like to apply it to map 2 and copy it from the map 1, the color table. Now, if I open the map 2 here, again, it will now be in the same color as the first one was. But the third is different. And I can't continue to do it for every map because sometimes I'll have several tens of thousands of maps. And when we're talking about temperature or rainfall data, you might want to do it for a very long list of maps altogether. And I mean, since you would want to have to do it for like so many maps together, you would need to therefore then use a technique or a method where you could like, just bulk do so. So what I could do is here, I could type a different command for I in g.list. Now, if you see, I have this reverse hyphen, this tiny hyphen here. and inverted. And this is in this I'm encapsulating my g.list raster command. So if I go back for here, let's say g.list raster, this is what lists the rasters for me. I could probably look at the help of this command, and if I see I have the type, the pattern, the map set I need to specify. So what I could do is g.list type raster pattern, and for the pattern part I could maybe use a separate kind of pattern, file names maybe. So I don't have different file names here, so I'm not using the pattern. And then I could use a separator. And then I could maybe use that uh, separator for that matter, comma maybe. And this it actually gave me these names separated by a comma. And sometimes for some of my applications or programming needs or something else, I might need to show these as such. For what I'm doing here is for I in, I'm encapsulating this command g.list type is equal to raster, pattern is equal to aesthetic. This means all files. To r.colors. Now, this I is a variable in which this list of file names has been saved. So I saved the list of file names that I was just displaying a while ago in this I. So if I had a different set of files like LST and rainfall both in the same data directory, so I could like select the rainfall separately and what do you say, the temperature file separately, and I could assign them separate color tables. So what I would do here is, but right now I don't have to, so I'm just doing for one colors $I, and then I could say for that matter the color. So the color choice I'm going to go with is Celsius, and when I say done, there's an issue. It's not working, so I'm going to use a separator, comma. Sorry. Sorry. This is a bit of a problem with me. I'm sorry for that. I know colors map is equal to $, my bad. And it just did it clearly. I'm sorry, that's a typo error that it. So now all my maps are in the degree Celsius color table. And it's good to actually have a degree Celsius, Fahrenheit, and Kelvin because your data range can be varying. And there you go. So we are in the winter months here. And it's like different. A comparatively warmer December. I wasn't expecting this. And then this, Feb. And then these are some summer months where the temperature seems to be really high. I'm going to add a raster legend for this. I'm going to say OK. And the maximum temperature for the land surface is up to 64 degrees Celsius. So, well, I mean, let's not deny that this can get actually really hot in some places. So remove the legend for now. And this is what I have done. I have my temperature table, color tables assigned. But if you must, or you must pay attention to the fact that this is actually a time series data. Now, since it's a time series data, there is something that really interesting that GRASS is capable of doing. It is actually capable of processing time series data as time series data for us. So now when it actually can do so, uh, I mean, that makes it really interesting because time series data processing capability in many GIS software are there, but not very much used by many people. And GRASS and alongside it R as a software are exceptionally capable in terms of offering those capabilities. So there's a command known as, let me show you that, GRASS GIS. t.connect. So t.connect is a GRAS command. So if you're working with temporal dataset, the command starts with T, and it's where you actually uh, set the first ever temporal GIS database connection for your GRAS workspace. So if you've never worked in these settings before, all that you need to do is t-connect-t, and the default driver for temporal database would be set for you. You could look at the help as well and see if you have other options. You could have other options, but usually for temporal data, you don't have MySQL option available, but you only have PG, that is Postgres, and SQLite. And by default, it has set a SQLite.db database for you, where it's going to store all your working files related information. Fairly good. I don't think this is going to be too much of an issue for anyone to just type t dot connect dash d and get connected to your temporal database. The next thing that we are planning to do here is actually create our spatiotemporal raster database. So what really happens is that GRAS has a terminology called STRDS. So it's called STRDS. This is a spatiotemporal raster datasets. And it is the same, I mean, it's something uh, very commonly you can assign. And there is also spatiotemporal or space-time vector datasets that GRAS works with. Uh, in case, I mean, if you would like to create a new GRAS GIS dataset, you can quite easily do that. For that kind of thing, you could already like, uh, plan before what kind of data you would be working with, because the spatiotemporal datasets can be of the daily type, 10-day interval type, monthly type, and annual type. So it certainly depends on what kind of spatiotemporal database types you would be wanting to work, and you can then assign mm, an interval to your dataset. So here we would be creating your first spatiotemporal raster dataset. What you're going to do is you're going to type the t.create command. I'm going to go into the help here, and it's going to tell you that you're going to actually have the name that you want to give it, the type. So is it raster, vector, or 3D rasters? Or 3D datasets maybe. The default is for raster. That means that it works better with rasters. And as I've already maintained and always maintained, that GraphGIS works exceptionally well with raster dataset. Then you have two other options. One is the absolute and one is the relative. Absolute is like given dates, and relative is with respect to the starting time that you are going to mention. Uh, Semantic types, that is the nature or explanation. So it's going to be like the minimum temperature data, maybe the maximum, the sum, or the mean data set. The one that we are working with are monthly averages. So this is the mean data set. For the daily data set, you're definitely going to use the mean because that's the default and that's fine. If you would like to assign it a title, you can do the same. And you can actually even mention a description to it as well. So I'm going to go with the T dot create. And the next thing that I'm going to do is I'm going to type maybe mm, the output name. And I'm going to say LST. And then I'm going to type, and that is STRD. The temporal type, I don't have to really mention. Actually, other things are by default as well, but I'll say absolute. Then I'm going to go with the semantic type. That's mean. The title, I'm going to say a bit with like some description on it, like the land surface temperature. monthly averages using models. And then the semantic type I've already mentioned. So what I'm going to do is I'm going to create, and there's going to be some description. So I'm going to give it maybe, I don't know. I mean, modest LSD monthly data for Pakistan. And I'm going to probably reduce the title a little to modest LSD. There you go. It's going to take a while, maybe a second or so, and my temporal database has been created. The next thing that I need to do is obviously set maps for it. And for that very purpose, what I would need to do is I'm going to actually have to register my maps into the spatiotemporal database. For that purpose, if you look at the maps that I have 12 maps. They're like 1, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What I'm going to do here is I'm going to use that t.register command. I'm going to type the help here. And this is where my t.registers works. It assigns timestamps. So the first thing I actually have to give the name that I just created. So it was LST, if I remember. I go to these previous commands by pressing the up key. So you could do the same. I mean, you could press the up key and go to the previous command. So I remember that I called it LST, so I'm going to use that as the input. Uh, I definitely need the names of my input maps. And this is going to be slightly tricky, but not very tricky. So what we did was I did show you that raster pattern is static separator is equal to comma, and I could actually list my name, the file names. So hopefully that's not going to be too much of an issue. And there's one thing that I probably could have done that is maybe I'll quickly do this maybe to put them in the right order. I could just quickly rename them. So I'm going to add a 0 to every name prefix. I'll probably in the future classes tell you how to do this in bulk as well. That's quite doable and quite easy to do. That will take us to something. If I do it now, it will take us to something totally different. So if I do the same thing, I'll be having 0, 1, 0, 2, 0, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's just to keep things in order. And this is something of an exercise that we do a lot in when we have to rename files in bulk. So maybe someday we'll do some exercise on how to do that on Linux. So what I'll do is I'll go with the t.register and start registering maps. So I'm going to type lst, I'm going to type maps, and here I'm going to then bring the same g.list command into play. So what I'm going to do is I'm going to type g.list type is equal to raster pattern is equal to LST. Separator is the comma, and this would be something that you could use. You can actually even type comma if you want to, but that's not necessary. Just the comma symbol is going to work for you. So these are the maps. Just let me fix this because it requires maps, not map, to be written there. Then I'm going to be type. So these are rasters. Uh, if I had a text file of file names, I could use the file option. But since I don't have that, so that's fine. Start, this is the start date. End would be the end date. And then the unit. So it's like years. So I would say, for that matter, start, and then I could just one quick second, I could look into the manual for T dot register as to what the date format should be. So it could be year, month, and day. I could probably pick one, and that should be fine. If I do not want to do that, I mean, that would be a bit difficult because usually it works that way. So what I'll do is I'll go with one date as a representative for the whole year. So I'm going to say 2000 dash. Let me check the format again. It's a good idea to the month and then the day. So that's the year, the month, and then the day. I could just go with 31, but I think going with 01 is fine for the reference. And would be 200 dash. Just one more thing. Just let me check if my file names. Yes, it's 2001, not 2000. So I'm going to mention 2001. So it's 2001, 12, 01. So it's the year, month, and day for the end. The increment is, I mean, I have months, so that's fine. If I would, for that matter, want to mention something, it's just I'm a little confused about the increment part. Just one thing. Okay, so I could, I don't need to increment them because there are 12 maps, so I think it should work. And because I'm giving also the end type, but if I'm not giving the end, so I could say, like, I mean, 1 month. So, I mean, if I'm not using the end date, I could say increment, and then I could use 1 month. So that's how it's going to work. There you go. That was pretty quick. And as a matter of fact, my temporal uh, uh, data set has been created. I'll have to go. I'm a little skeptical as to what it's doing because it doesn't look right to me. Just give me one second. I won't go with the one part like this. I'll go with the end part. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has pretty quickly registered all my images, and I don't need to, because when it said 100 only 2 times, 100% only 2 times, so it got me a little worried. Uh, and I thought I should just double check. So all of my uh, temporal datasets have been registered. I'll go with the g.list, and then I'm going to type spatiotemporal raster datasets. Uh-huh. No, this is not right. T.list, sorry. So when T dot list is an alternative of a G dot list. So when I type T dot list, it will tell me my temporal data sets. It's going to tell me as to how many temporal data sets I have uh, stored in with me. So I'm going to type T dot list, type spatiotemporal raster data sets. And if I would like to maybe type any of the other things, I could do so. But I don't need to do so. So it's going to just, type it for me, and it's going to tell me that I have a temporal data set database with LST at the rate of permanent. So in the permanent workspace, my spatiotemporal database is stored. I could obviously type some other information regarding this spatiotemporal data set. I mean, for that matter, t.info. And then I could say, again, help, because I don't remember everything usually. And then I could type input LST. Hmm? T.info LST. It should work. Yeah, it will print the information for me. Now it's going to be telling me a lot of things about the space-time raster dataset that I created. So there's some basic information that it's of the type absolute. The creation time is given. The start time is given. The end time is given. The granularity is calculated automatically. I did not actually had to tell Grass GIS if it's 1 month or not. I did type 1 month in the beginning, but I removed that, and it automatically calculated based on the start date, the end date, and the fact that these were 12 maps only, the spatial extent of the maps. So these are predefined. The metadata information that I would need, the north-south resolution, the north-south maximum or minimum resolution, the east-west, and everything else. Usually we don't care about this kind of information. And the command history. So as to what commands did I run on this raster dataset, spatiotemporal raster dataset. The commands that I ran were like the maps 1 month and the start and the end. Both would give me the same results, so not a big deal. The second command produced an error because it could not rewrite the first one. And that usually happens. That should not be too much of an issue. If I would like to maybe do some statistics, maybe uh, univariate statistics, so I could type the t.univar command. What? It should do so. Yeah, there you go. So the raster univariate statistics, so it can actually calculate some statistics for me on the input spatiotemporal raster dataset. I would try that. Maybe input LST. Wow, that's quite a lot of information. For anyone who would like to read that properly, the easy thing is uh, univar underscore lst.txt. You don't have to give an extension here on Linux, but let's do that. The file would now be saved. I'm going to type leafpad univar. I don't have leafpad here. Oh, featherpad, sorry. There you go. And my text file is here. Provided I'm working on my Windows at the same time, I could just go to my downloads, get into this folder, and I need to see which folder I am in right now, actually. I'll have to go to Media SF Downloads 2001. Yes, this is where the folder I was in, and I could retype that same command. I'm gonna go for Excel maybe here. drop this file in here. No, not going to work this way. Let me mm, going to skip this part, close this, and probably create a blank file. And it's going to ask me to import this one. So I'm going to say that my data does have headers. So yes, it does. I'm going to say that it has a separator, but it's different than the common separators. And it's going to create columns. I'm going to go with next. I'm going to type finish, and it's going to tell me the statistics for all files. So I have these statistics for LSD 2001 for the month of January, February, March, April, May, June, July, August, September. And these have a start because there was just one date, the mean temperature for each, the minimum for each, the maximum for each, the mean of absolute, standard deviation, variance, coefficient of variance, the sum of all cell values, the number of null cells, the total number of cells, and the non-null cells in my map. And this is, I could do that with 10 files or 12 files all together in one go. And that is something that is critically interesting. So to say, obviously, the least, if at any point you would like to list other things like t dot list, sorry, t dot raster dot list input is equal to lst. And if you would like to do so, it will actually list files for you. And I mean, in the end, it's going to call, like, say, this is for the 30 days, this is for the 31st day onward, this is the 59th day onward, this is the 90th day onward, and this is 334th day onward for you. And this is something that you could, like, uh, you could experiment with things. So if you go with the t.raster.list command and type help, you're going to actually find that there are certain iterations of the same commands with different input values that you could try. It certainly depends, I mean, on what you would like to do. But I would rather, since you're doing it for the first time and you are doing it as an exercise, I would invite you to actually try these combinations. Pick one method, pick a comma maybe, or something for that matter, and see what it does. Like for that matter, if I say input method uh, renewal, I would rather say method list. And the moment I say that, the list now I'm going to get. And you could probably use a separator. So generally, the pipe separator or the vertical separator, this separator, the pipe is this thing. So you could probably pick, you can say comma, I want to use the comma separator for that. And it's actually going to be then commas. And these can then help you if you would like to enter these file names somewhere else. I mean, for that matter, I would like to share my file names with someone. So I could say file names. And then when I open this, I'll get these file names and I could send this text file to my boss or someone who is working with me in the team. And these are the files that I have. I mean, this is something that you don't really always need to do, but sometimes you need to export these file names to do some other maybe GIS related operations on them when you're working with bulk data. So that's it where it gets really, really interesting for most of us. Uh, there's something that you could do also, that is put it on display on the screen, the time series. So this is g.gui.timeline. It's going to probably take a while to load. There you go. It's going to tell you the timeline of your data set, and you're going to actually visually see how your granules are placed. And this is, I mean, if you would like to 3D plot the spatiotemporal data set, there you go. So I have a 3D plot as well. And if there is somewhere that I would like to show that, I could do that as well. Now, the 3D plot is here, and I could show my 3D plot as such as to what the spatiotemporal geographic extent of my data set is. So what I could do is, I mean, we are all talking about geovisual analytics here. So from that point of view, this is something interesting because not very neat, but you can see the vertical layers, the dates mentioned, the degree extents mentioned. So you could probably export this, you could play it around with it a little and then export it as an image or a file and then, work on it. If I had other spatiotemporal raster datasets, I would have been able to do it with them at a given time. You could also, tplot is a function which is known as the time series plot function. And sorry, not input, strd is equal to lst. There you go. So you could then obviously do graphs on them. Working on LST, yes. If you would like to mention a certain given set of spatiotemporal coordinates, you could do so. I mean, I could, for that matter, 6729. So I could do 6729 here and draw how temperature changed at that given latitude and longitude from the first month of the year to the last month of the year for the surface. And if I see, I get a very interesting graph that is starting from somewhere below 15 and going up to as high as 40. I could maybe make it 31 and then draw a different graph. And I have added a linear regression line to my data set as well. Now, if you have a very long range of data that you would like to do that for, I think that could be interesting. And I mean, uh, there's so much more that you can do with it. But since we are nearing our 50 minutes mark, so I'd like to stop here. Uh, we have somehow worked with a few basic functions of spatiotemporal raster datasets. You could do the same with vector datasets as well. I would invite you to go through these videos, do your exercises, and now turn on the mics for every one of you. If you have any questions to ask, please do so.